Hello everyone, this is Sonali. Welcome in day 7. So today we are having amazing co-host Manoj and super excited speakers Rupa, Pragna, Naresh, Saurabh and Sandeep. Welcome all. Let's start today's session. So the first question I will ask to Pragna. So
Okay.
the question is, you allocated a dedicated host, but see that utilization is low. Suppose you took a dedicated host, and whatever application you are running, you created virtual machines there, and you are running the application. But whatever you are organizing the dedicated host, that is not properly utilized. So how you are going to optimize the instance placements according to the size of dedicated host?
Uh, okay. So for this, like the dedicated host is the dedicated host is the like build and we will get a bill per host, and it is not per instance. That is the main point we need to cover it here. And along with that, as mentioned in the scenario, the utilization is very low. So while designing and considering for the solution, we need to think about as it's underutilized, the vestige of money should not be there, so we need to plan it accordingly. So here for that we can launch the multiple EC2 instances, so those from the different family and different sizes. And but here again it's a dedicated host, so we need to consider that those should be fit, those instance families which we are choosing, and the sizes those should be fitted into the host capacity. Along with that, we can use the functionality of auto placements in the AWS, so that the AWS can automatically place those instances, and we can the underutilized hosts which we have. So those along with the auto placement, we can improve the usage of that, so the underutilization not happen. And along with that, the one another functionality called the host affinity in the AWS, we need to ensure with the functionality of the host affinity, so that all the instances, those which we are launching, so those should be in the same host. So with that, we can achieve this scenario. So yeah, that's all for the scenario from my side.
Okay. Yes. So as you talked, dedicated host, we are going to pay for the particular host. There is not we are going to pay for the particular instance wise. So suppose you are creating one large instance. Suppose you are creating M5 X25X large instance. So in one dedicated host, you are creating one large instance, and you are creating another dedicated host. In that, you are creating a small instances, and there in between you are having the gaps that is not utilizing it properly. In that case, if you are using recovery automated that service from the AWS, that automation see the from the AWS, and it will going to, when you are restarting that particular instance, it will be automatically rearranged. So if you are using two instances, but that particular sizes it fit in one instances, then that will be going to be used in one instances, and other dedicated host it will be going to release. So in that case, we will going to uh, benefited with the cost optimization also. If we don't want multiple dedicated hosts, then why should we use now? So we can use AWS services to automate for the recovery purpose, and that will be beneficial for use. Instead of taking the manual headaches, we can go for the automation from the AWS services. Yes, now we'll go ahead with the next question. Yeah, you can understand the scenario properly with this example also. We'll go ahead with the next question. Yes, Manoj?
Yeah, I'm going this question with Saurabh. Hey, hi Saurabh. We will discuss this. Here, the scenario is like this. we have a dedicated host which fails. How would you recover this dedicated host whenever your complaints needs to match? Because whatever our workload is there, it should not affect. Okay, then how you will manage this without affecting our compliances?
Okay. So for this scenario, if the dedicated host fails, the
Hmm.
compliant rules means that I can just move the workload to the shared tenancy. So the best approach for that is that to use a host recovery, which automatically reprovision the workload to the another available host in the same availability zone.
Mhm.
If it's not available, then I allot a new dedicated host manually and redeploy the instance using the AMI, means Amazon Machine Image, and the EBS snapshot also. So for that, and then the documentation is important too for that. So CloudTrail and the license manager must show a workload or always stay on the complaint hardware.
Hmm.
So we can take example like that when the work with the HIPAA workload means Hospitality Act. We have the secondary host allotted as a part of the HA
Hmm.
availability. When the one host failed to be simply shifted the instance to the backup host without breaking our compliances.
Hmm.
That's
Yeah.
me.
Yeah, very good covering the answers. And just I want to recall whatever you mentioned just for one structure level. As we know that we have a dedicated host. If that fails, but our workload will affect. That is our main criteria. There we need to avoid that issue. Okay. Here, what we are doing, like in our company and others also, we just doing the health check, AWS health check using CloudWatch for this physical server basically. And here when we monitoring this everything, and also we will identify if whenever this dedicated host going down. So what we do, we will start this, already we dedicated host. In that one, entire physical server they are giving us, we are managing entire server itself, that physical server. So here we are enabling one feature like host recovery. Basically, what it will happen if we enable host recovery, AWS will take care. If any physical server is going down, is any issue in the physical server, then AWS will check those things and they will manage. They will fix that issue. Okay. So we no need to check every time, every second this AWS monitor. So and also we are going with the some approach like auto scaling group. Okay, this is like something new feature we are using here. What we are doing, we creating some dedicated host, and we will keep one group, make it using those dedicated host. We are keeping one creating one group that is called what we can say, a host resource group. Okay, these host resource group once we created, and also we will create a capacity reservation basically. Okay, we integrate these two and we will add these things with the auto scaling group. Okay, whenever there is anything going down, okay, that time this auto scaling group will move our whatever instance to our capacity reservation. And in the same meantime, AWS will replace our default physical server. And again our application will run continuously without interruption. Okay, this is the feature we are using. And also here we are using the AWS config rule. Okay, so it will match our compliances, everything. Like this, we can fix our issues also, and without manual intervention most of the time. So it will everything is having the automatic. Yeah, this is like this. So we will follow to fix this issue. Yeah.
Okay, we'll go ahead with the next question. So
Yeah.
I will ask the next question to Naresh. So the question is, your YAML training job is running slowly on a compute optimized instance. Okay, you are running one ML job. So that is running on compute optimized instance, and that is running very slowly. So how would you determine if you need a GPU instance or you are going to continue with the CPU one. So what is your approach? How you are going to determine? Can you explain?
Okay. Uh, let's say you are saying like uh, training an image classification model on uh, like if we use on a CPU instance, uh, it port each port takes 60 minutes because CPU process metrics multiplications slowly. For example, CPU utilization is 100%, memory is okay, but it is progressing slowly. If we switch to GPU instance, um, each port takes 6 minutes. Means it is 10 times faster because GPUs handle matrix in parallel. Uh, that's why GPU utilization is 100%. CPU is free for data loading. In this case, GPU is clearly the better choice, I can say. And uh, if we run a small benchmark of our training job on both CPU and GPU with some subset of data, we have to we can compare the time for each watch. If GPU cuts down training time significantly, it's worth the cost. If GPU does not improve speed, then we can stay with the CPU only. Uh, for example, if you decide if GPU is better, we have to check if your workload is CPU bound due to heavy matrix ops, or benchmarking training speed per epoch on CPU versus GPU. Like this, we have to check compared to GPU and with CPU. Choosing GPU only in this model benefits, I can say.
Okay, great. So here we are running ML training job. So on that job, we are directly not going to means jump into the GPU, right? First, we have to test the things how it is working. So if the processor is CPU bound, so that is we are going to use for data processing, feature engineering, small models like that. But it is a GPU friendly, then we are going to use for deep learning, neural nets, or large tensor computations. So for that, we are going to use a GPU friendly. But without means testing, how can we directly jump into the GPU? For that, we have to first test the CPU utilization, memory utilization, or disk utilization, GPU libraries, all the things first we have to test, and according to that we have to take the decision. So what we are going to do, we are going to take a small portion of job and that we are going to run on both the instances, and we will see the output means the time and cost, in how much time it will be producing the output it is taking. Both the scenario we will check all the things, and then depending on that we will take the decision. Suppose you are running one job on CPU based, there it is taking 1 hour. The same job you are running on GPU based, there it is taking 5 minutes. So then in that case, we will move to the GPU base, right? So this is the scenario. So if we can compare according to cost also. Suppose the job which you are running on CPU instance, that is charging $1 per hour, or like that. So if it is 50 hours, it is $50. But if you go for the GPU based, it is charging $10 per hour. So it is, if it is taking 3 hours, 3 hours, then it costs me $30. So if we see overall, then CPU based it is charging $50, GPU based it is charging $30. So by considering overall result, we can save money in GPU based, and we are getting result faster. We are saving time and money, both the things. So in this scenario, we will go with the approach GPU based. Yes, I'll go with the next scenario. You can use this diagram to understand the particular scenario proper way. Yes, Manoj.
This scenario, I'm going with Rupa. Hey, hi, Rupa. We have like some of the scenario we need to discuss. This is on ERP system like that. Here, our task is we need to migrating our Java based ERP system from on-prem, like our in our own data center to the AWS. Okay, so how would you determine the correct instance type and size before you migration? Because when if there is any mismatch, then maybe we are doing over provisioning or we are doing under provisioning. If we do over provisioning, then our cost will be very high. If we do under provisioning, then our entire system will collapse. This situation we will face. So how you will determine this instance type and size?
Okay, sure. So firstly, the first step would be to gather our current matrices.
Mm.
Means before sizing anything, first we would analyze the on-premises systems like CPU usage and memory usage, input, output, and also the network usage. And
Mhm.
then we would map our workload characteristics to AWS instance families. So usually our applications like ERP applications, for example, like Oracle e-business suite, SAP applications. So these are typically memory optimized and computer balanced. So
Mm.
for ERP, we would usually configure with R family or M family instances, because ERP workloads tend to be more memory heavy. So that's one thing. And second thing is initial right sizing. Means we don't need to over provision like our on premises. So we can scale vertically, that is with the bigger instances, or horizontally with the help of our load balancer nodes as our usage grows. And next, we should make sure that we test our proof of concept, that is by running our load testing, and measure our response times, throughput, CPU utilization, and such configurations. And then based on these, we need to measure the response time, throughput, and CPU utilization under stress. So these are the steps we should take care of while configuring with the type and size before the migration from on-premise.
Yeah, very well you covered this scenario, and as you mentioned, this R family and M family, that is very a good choice. And also, while we are when we are testing the size of this our application, we just using this AWS migration evaluator, and also we will check the realistic performance of the load, and then we will finally we will identify the right size, and then we can. So we can stay around like the 60 to 70% at a peak size. Okay, we are not going 80, 90 like that. We just keep 70% as peak, and later we will optimize the like this cost and other things also. Like this we can you go with the reserved instance also, or a saving plan also, because this database and those things which we are going, right, this is very long term. Even though we are growing, when in our application we will elaborate our testing, and also we will do the high level testing. If we are taking one process of Java, then the same process will may increase more than 100 times. So this reserve instance also is a one good plan for cheaper cost doing with this migration plan. Like that, you also covered very well, Rupa. And we can utilize this diagram for our next use.
Yes, we'll go with the next question. I will ask this question to Sandeep. So the question is, Sandeep, your EC2 instance is hitting a 90% of memory utilization, but only 30% CPU uses. How would you scale, vertically or horizontally, and why? That you have to mention. It's here. Uh, your memory utilization is more than CPU utilization. So in
Okay,
this scenario,
so in this
yes, explain.
o- okay, so in this scenario, the memory utilization is 90%. So it is the bottleneck in the memory, or CPU utilization is a 30%. So CPU is underutilized. So I would prefer the choice for go through the vertical scaling. So it means we can add the bigger instance with the more memory, because of bottleneck is a memory, not a CPU. So we can move to the memory optimized instance family like R5 or R6. For example, if we are using now M5 large, so we can move to the R5 large family in this case. So, and vertical scaling is best fit for the stateful apps like ERP, database, or caching related. So that can't be easily distributed. But there is a disadvantages. So it is a single point of failure, or you have a hardware limits, or it may be rise in cost. And if you go for the horizontal scaling, so we add the more instances behind the load balancer, but we distribute the only load, but the memory constraint is still there. So I think we can go with the vertical scaling here.
Yes, exactly. Here, as you told, yes, bottleneck is memory, not a CPU. So if we go through the vertical scaling, that will be a good option. Here we can increase instance size to with more RAM. Means we can move T3 medium to T3 large, or we can even jump to memory optimized instance size type. So that will be best option according to this scenario. So, thank you so much by explaining all the scenarios in a very deep way, in detailed way, according to your expertise, your experience. And if you are having some interview questions, you don't understand how to tackle, how to understand the particular scenario, or you are rejecting because of the scenario or not understanding, so you can feel free to reach out to us for I would be happy to help you. And our speakers, co-host, all is ready to help you. If you have any queries, any questions, or if you want any career guidance related to your future, or if you are currently stuck in any situation or same position in the job level, if you want career guidance for that, so feel free to reach out to us. We will happy to guide you. Thank you so much. Thank you all the amazing speakers and co-hosts. Thank you all.
Thank you. Thank you.
Thank you all.
Thank you.